All right, let's get started. Welcome, everyone. We're thrilled to pull this together to walk through the fantastic updates that the radiology planning and technical committees have put together for oops, there. For everything that we're doing in the radiology space in IHE. So we've got a jam-packed agenda. If we want to jump to the next slide. We're going to just do a very quick overview of what IHE is and what we do in the radiology domain. And then we'll walk through all the updates that have transpired over the past year. We're going to walk through AI result approval for imaging, point-of-care ultrasound, enterprise-based imaging workflow extensions, the cross-community web-based access to DICOM objects with WADO, and then hit on a couple of updates in the technical framework itself with the rest of the profiles, cover what's next, and then with the time remaining, we'll do questions. Just from an introduction sake, we have a number of speakers. I'll have everyone introduce themselves when they present their sections. But for me, I'm Brad Generu. I am the RAD Planning Co-Chair, along with Kent, and we lead half of the group alongside the technical committee who spends their time putting all these fantastic profiles together. So let's go into the next slide, and I'll just give, for those who don't know what IHE does, I mean, you're here, so I'm sure you have a sense, but just a quick recap, providing healthcare frameworks for interoperability, harmonizing the standards across all the different parts of what we see in healthcare and beyond. So this is profiling standards like HL7, like DICOM, and all the other, I'll say ontologies like RADLEX and LOINC, and pulling them together in service of the workflows that we see in hospitals, where it's super important that we have cross-application workflows. A community focused, built by the community, supported and developed by both the vendor side as well as all of the physician communities, user communities, to help pull this together so it's useful for everybody. The integration profiles that are created are freely available to all, can be used to help drive things like RFPs, to help drive knowledge and awareness, to simplify and harmonize the way that we integrate different applications together in order to solve healthcare's overarching challenges, to pull it all together so that life is easy for physicians and ultimately for the patients. There's not only the drafting and development of the standards of the profiles themselves, but also activities around validating applications, using events like connectathons to be able to test these applications together in a phenomenal space year after year, both North America, in Europe, in Japan, to drive this forward. Go to the next slide. Just to show some of the breadth of the profiles that are developed across the board in radiology. If you think about the workflow of ordering an exam, protocoling, acquiring images, reading the images, writing the report, and distributing that, there are profiles across the spectrum that IHE Radiology has developed. And so you can see, kind of from left to right, the profiles that we use, like scheduled workflow, like radiation exposure monitoring, imaging object change management, AI workflow for imaging, step-by-step power, the prioritization of workflows for reporting, XDSI, XCAI, and then down to the bottom, we also have papers to help support all of this as well. And so each of these are designed to help developers and ultimately implementers and deployers in order to connect these applications together. And there is a ton of information available up on the IHE website, IHE.net. Great place to get started. So with that, let's jump into the first updates for this morning's call. If you want to go to the next slide. We'll talk about AI result approval for imaging, and I'll turn it over to Anjay and Mark.
Hi, good morning from my side. My name is Antje Schröder. I'm with Siemens Healthineers, and Mark Kemmerer from Visus has together with me, or we have together worked on this profile. Actually, note Brad had IHRA with an I at the end. Since we thought that is unpronounceable, we just left the last I out, but the name and the content still stays the same. Next slide, please. So AI is becoming an essential part of the radiology routine workflows, and for users to have confidence that the AI solutions behave as they want. And also there's regulatory requirements, as for example, in the EU AI Act, there is this necessity to do performance assessments for the algorithms. That is the regulatory aspect is one important point. And also we want to make sure that for subsequent uses in clinical routine, only valid and evaluated AI findings will be used, and not just everything which is created by the AI. So with that, we thought it would be really important to give or to develop a profile which could encode the outcome of these assessment processes, which then will be part of the AI radiology portfolio, as you perhaps on the next slide you can see. Jane, if you could. So IHE Radiology has already started developing an AI-related portfolio a while back. There is the AI workflow management, which is the overarching profile, which manages the AI workflows, assigns tasks, and so on. Based on that, there is the actual encoding of the AI results by an evidence creator. So that creates AI objects of various types with various findings, which we obviously, before they go into the actual reporting process, want to do the assessment on, which is the scope of this profile. So, and then we have like profiles managing the actual report content or the information of the report, information sharing, like the IRA, which does the Firecast-based communication of AI results, or could do. And then we have the content profiles, which actually define how the actual radiology report may look in either in an interactive multimedia report or in an imaging diagnostic report. Next slide, please. So now let's look into the whole assessment of AI results. Basically, if you look into use cases, we need to cover the actual assessment process, which can occur either during a clinical reporting process where a radiologist selects valid findings or clinically relevant findings that he or she wants to see in the actual report. But also one can envision scenarios where, for example, for algorithm deployment, you may want to do a more thorough analysis for QA purposes. And then there is obviously the aspect of later on accessing the results of the imaging data, of the assessment data, similarly as stated above, for the clinical use purposes, where you just want to make sure that the referring physician or even like another radiologist who uses this study as a prior only sees the valid AI results. And then there's this whole aspect of QA. We called it QA analysis, which could be for doing performance measurements of the AI algorithms during clinical routine. So we can calculate performance metrics from the information derived. One could use the information to just create some dashboards, and one could also envision using the information for troubleshooting of AI solutions, although not all these use cases may have all the information that is needed. We defined or there may be other sources necessary, for example, to do a troubleshooting of an AI solution. Next bit, please. So for the scope of this profile, what we wanted to achieve. So one big assumption that we put into this whole thing is that we want to encode the results of this assessment process in DICOM. And we wanted to persist this data, this assessment results for the two use cases, as I had mentioned them, for the clinical use, as well as the QA analysis. And for the clinical use, we must strictly control access to invalid findings so that we really avoid misdiagnosis. So potentially we may actually need two different access mechanisms, because for QA analysis, you may want to have more detailed input as to what the findings are. So with that, we decided to use the IOCM, the image object change management means to manage the access to this information. And also one big assumption that we put into is that we want to deal with multiple AI objects or multiple DICOM IODs that could carry AI information. You can see the list, some of the examples on the right-hand side in the table. And the interesting thing there is also we have like objects which have structured information, like a structured report where you can have very detailed information about each and any nodule, for example, in a lung study with outlines and measurements and so on. But we also have like the DICOM objects, like a secondary capture, which basically where the whole object itself is the AI result, where we not necessarily can evaluate each and any single annotation that is burnt into the secondary capture. But we want to make sure that we can support both of these types. And also for the future, we need to take into account that the review or the assessment may be performed by human people, but also we could envision that there's LLMs or some other automated mechanisms performing another assessment after the human. So the whole process must be able to support these types of assessments. If you go to the next slide, please. So with all that, we started thinking about what we need to do for the encoding of the assessment results. And so basically, we have 3 steps associated with that. So first of all, we create output or updated AI result objects. For example, in the context of an SR, if we have 5 lung nodules, of which 3 are valid, 2 are invalid, and perhaps there is one which the algorithm has missed. So we create a new DICOM SR, which contains the accepted findings, the new findings, and will definitely not include the rejected ones. However, we also create what we call the assessment status object, which is also a DICOM SR using a TID. That is the outcome of this profile, which provides the reference into each finding as well as a status associated with these findings. So basically, whether the finding was accepted, whether it had to be modified, but also rejected, added, or the 2 scenarios which that they have not been reviewed, or that the user may not have been able to perform the assessment because he was unsure what is. There is something in the image, but the reading physician isn't sure what it is. And then, as I had stated, we want to make sure that invalid information cannot get into the circulation by when a referring physician or another radiologist looks at it. So we create a COS object to reject all the original AI or the input AI result objects, so that then there need to be special care mechanisms to access to them. So profile-wise, this was the main piece of work. The transaction used are actually the transactions as we know them for storing, querying, retrieving, and also for the storage of the rejection node, where one special point is that we transitioned or we put in a CP to make this transaction for storing the rejection node also accessible for web services. So with that, all the storage and query retrieve and transactions will be supported in both the DIMSI fashion as well as the web services version. And then on the next slide, please, we just depicted how we think this assessment workflow would work. So we have for each assessment step, we have an input file. Actually, so basically, for this example, we have a DICOM SR, which has 3 findings. Each of them is identified by a unique identifier. In the context of the SR, it is the observation UID, but if we have a segmentation object or any other object, there are unique identifiers defined for those as well. And also resulting from the AI solution is a secondary capture image, which is basically an overview which contains the 3 findings in, like, for example, 3 lung nodules in a frontal view. During the assessment process, it actually turns out that the observations 1.1, so 2 of the nodules, and 1.3 are valid, so they get copied into the updated SR. The second one is invalid, so it is removed. And then we add another one coming into the, which the AI was overseeing. So, and then the additional output steps, as I had mentioned on the previous slides, are the assessment status SR, which uses the observation UID and references into that one. As you can see, for the accepted or modified findings, it references them into the updated, the output assessment, the assessment output SR. For the rejected one, since that is not in the updated SR, it references into the original AI results, so that if you want to do some further investigation, you can take a look into that one and identify whether that was, what may have caused the problems. And I had mentioned there's a secondary capture, which gives an overview of the 3 findings. But since there was invalid information on, like the second nodule is missing, as well as was present, which is invalid, plus there's 1 missing nodule, the aim is to completely reject that object as well. And then the last step, as you can see below, is that we have a cause object created, which we title by rejected for quality reasons, assessment outcome. And that gives references the 2 original AI results as invalid. And so this was a 20-foot high-level overview of the profile. I think Q&A is later on. Yeah, pretty much for now, that's the end of our presentation. Thank you.
Great, thank you so much. And next slide. So next up, we will cover point-of-care ultrasound, EVIW extensions. I'll turn it over to who's covering this. Steve?
Steve Nichols from GE Healthcare and Rob Ferry from Indiana University. So
perfect.
Rob, I'll let you kick it off.
All right, let's go next slide. All right, so previously in the encounter-based imaging workflow profile, there were a very brief, high-level overview of point-of-care ultrasound. But despite this, we still have run into a lot of problems. And primarily, those of us, like myself as an emergency physician, there was a lack of standardization in how this was done. And so from the imaging community, people were trying to implement this, but it was fragmented because there was not good guidance and standards that existed. From the clinical standpoint, as representing the American Colleges of Emergency Physicians, as physicians, this impacted us in many ways because we weren't able, while we were using ultrasound, we really weren't able to document it. And essentially, each institution was its own laboratory, having to create its own imaging workflow. And that created a lot of frustration in trying to work with different vendors and to try to create some standardization. So fortunately, about 2.5 years ago, we formed a work group and were able to get a large group of people together to help frame what the community wanted and also help put this in a technical framework. Next slide. So over this 2.5 journey, we went to several meetings. And so Steve helped from the technical standpoint, helped a lot with this, but we went to different professional societies, different national meetings to get the use case and clinical perspective. And so after all of the listening that we had done and having a lot of clinicians on this work group, basically what we said is, what is our POCUS workflow product? And essentially what it is it's a point-of-care ultrasound study done on an identified patient, performed by a clinician with point-of-care ultrasound privileges, where images are archived, a report is signed, and all of that is viewable in the electronic health record. Next slide. So work had been done previously by early founders using a scheduled workflow where, using a traditional radiology-based imaging workflow, an order would be placed by the clinician. The operator would be identified, the correct patient was identified using this modality work list, and it went through PACS and eventually into the EMR. But the problem is clinicians that are seeing patients don't order themselves to do anything. I mean, it is not what we do. I don't order myself to auscultate someone. I don't order myself to palpate someone's abdomen. So it's very disruptive to the workflow, and it's not how we do work. And so an encounter-based imaging workflow is what works best for us. And actually, I did some surveys from our 1,500 plus members in our emergency ultrasound section of ACEP and found that the vast majority wanted an encounter-based imaging workflow. And so that's what this describes. And so next slide. So this point-of-care ultrasound workflow is described here. And basically, the core part of this, and Steve will talk about this in a minute, is what we describe as the point-of-care ultrasound manager. And the point-of-care ultrasound manager is able to do the things that are necessary for this encounter-based imaging workflow. The gist of this is that when a patient is registered, that populates the modality work list. We also have identified operators, they're known operators through Active Directory or through some employee directory that the hospital has. And those operators are managed by the POCUS manager in knowing if they have point-of-care ultrasound privilege or if they do not. And one of the core components of point-of-care ultrasound is that we are always, it is different than traditional workflows in that we are always training new physicians to become privileged. And so there's always some element where I have someone doing point-of-care ultrasound exams that may not be fully privileged to do them. And so that needs to be accounted for. And the reason why we distinguish between operators who have point-of-care ultrasound privileges and operators who do not. And the point-of-care ultrasound manager helps us to do this. And eventually, receives that completed study where a report can be completed, and then images can be archived to the VNA, and the report with linked images can be found in the electronic medical record. Next slide. Steve, all you.
Great. Can everybody hear me?
Yes.
Oh, good. Okay. My microphone showed it was muted. Thank you. Yeah, so in EBIW, the existing actors fulfill their same roles. So we have the encounter manager, acquisition modality, image manager, image archive, and results aggregator. So those in point of care ultrasound fulfill their same roles. What we did in the POCUS option was we introduced, as Rob had mentioned, the POCUS manager. Now, in real world implementations, we see that the POCUS manager is typically grouped with the encounter manager and image display, but the POCUS manager has a pretty large role in this workflow. It manages worksheets, which is the predecessor to reporting. It verifies operator privileges, confirms the operators, confirms and separates training studies from clinical studies. It generates study instance UIDs, session numbers as needed, and it sends those final reported results to the results aggregator. And as Rob mentioned, this is all focused around the fact that in point of care ultrasound, the healthcare delivery organizations are responsible for their own privileging for POCUS operators. So unlike radiology workflows, all of that stuff is governed by the state or other jurisdictions. So there's a pretty heavy burden on facilities that implement their own POCUS programs. Next slide. So we developed several use cases, though the EBIW originally included one use case, so we expanded these to 4. These were established with working with ACEP Consensus Group, obtained lots of feedback through SCUF conferences and other forums. But what we wanted to make sure is that we encompass training, reporting, and we differentiate diagnostic from procedural ultrasound, because it was some of these seem to be areas of where we wanted to make sure there was consistency in the POCUS space. So the diagnostic POCUS, that's your typical diagnostic study performed by a privileged healthcare provider on a registered patient. So this is your happy path use case. A training only is a POCUS learner conducting an ultrasound study without a registered patient. So they're performing POCUS on a coworker or in a lab. This is solely for practice. And then the third use case is the mixed use case, which we see quite a bit at teaching hospitals, where you have a POCUS learner that's performing a mixed study on a registered patient. So a patient may, in this case, the learner would actually ask the patient, "Hey, while I'm here, do you mind if I scan your kidneys?" And usually the patients agree to that. And so in addition to their clinically indicated studies, they may have some training studies as well. And all of these studies need to be sorted out accordingly within the POCUS manager. And so we cover that in this particular use case. And then, as I mentioned, the procedural study, when it comes to using ultrasound guidance, the reporting can get a little tricky. So we wanted to make sure that we had a use case to reflect that and standardize that as well. Next slide. So the transactions are unchanged as well. So we didn't introduce any new transactions. What we did was we added POCUS options to the existing EBIW transactions, and then we reused the scheduled workflow transactions for image display. So not a lot of change here. Probably the biggest change that you'll notice in looking at the profile is that RAD 132 now actually includes several reporting components. A lot of these were borrowed from RAD 128, which is a very similar reporting transaction. So other than that, the transactions mirror what we have in EBIW today. Next slide. So in an IHE profile, the concept section of volume 1 provides underlying principles, assumptions, and key elements that guided the implementation of integration profile. So this is kind of like our encyclopedia of information that we used as guiding principles when it came to developing this profile. And so through the work with ASAP, we expanded the concepts section with several areas that we have listed here. Again, we've mentioned these privileging and training are a big part of point of care ultrasound, and the distinction between privileging and credentialing, reporting. There's all kinds of workflow challenges. If you consider scheduled workflow has inherent checks and balances because of the multiple people that are involved, things usually work out fairly well. Well, in point of care ultrasound, you really have a clinician who's performing, reporting, and archiving, responsible for archiving the images. So you really have a single failure point. And so we wanted to highlight some of the challenges that comes along with that. Billing is a big topic. There's lots of ways to integrate with EMR systems for billing. So we added lots of concepts on that, and we explained some of the variables that we have experienced in the marketplace. Of course, handheld devices easily come and go from networks, so we included that. And then there's lots of issues with merging studies and separating studies, so we want to make sure we touched on that in terms of a appendix. Next slide. For the implementers, we also added several appendices. We updated the existing procedure reason code. So we added codes for trading, or we added one code for trading. But we also added several other appendices of mapping of DICOM attributes for the POCUS modality, HL7 ADT mapping to modality work list. That's although the profile doesn't specify a way to create the modality work list, ADT seems to be the most common method that's used. So we created a mapping, informational mapping, to help implementers with that. And then we have a similar mapping on the reporting side of DICOM to HL7 for reporting, so that we can ensure metadata consistency across DICOM and HL7. Next slide. So as Rob had mentioned, this was really a joint work effort with IHE and the American College of Emergency Physicians. So wanted to call out Rob's help in leading the team to develop this, as well as several others in the work group. We used lots of time during the Society of Clinical Ultrasound Fellowships meetings. So want to thank those folks. Without all their help, we wouldn't have been able to put together all the feedback that resulted in this profile. So thank you for everyone that contributed. And last slide. So just QR code will take you directly to the profile itself. Of course, this is in trial implementation, so we're still accepting public comments or any feedback, and then look forward to some POCUS option testing at the 2026 North American Connect-a-thon. Thank you.
Awesome. Thank you so much. All right. The third profile update, the cross-community web-based access to DICOM objects with WADO. I will turn it over to Andre.
Yes, good morning, good afternoon, everyone. I'm Andrei Leontiev, Senior Solutions Architect for Visage Imaging and a co-chair of the IHE Radiology Technical Committee. I was one of the authors of this profile, but I'll have to mention many contributors who have been very helpful in shaping it to what it stands right now. As you can see, we had a very busy cycle. We probably a little bit overextended our allocated times and ability to stretched our ability to deliver. But as you've seen for two profiles that were just presented, they're addressing very real needs in real environments to address. And so is this profile, which has been drawn on the strong demand for sharing DICOM objects between communities, between the healthcare communities, to allow continuity of care and access to complete patient's imaging record. This demand is coming from a variety of countries, a variety of environments. The bottom line is that in today's healthcare environment, more and more the need for information exchange is crossing not only enterprise boundaries, but also boundaries of regions or communities which are served by separate healthcare information exchange networks, whether those are geographical or administrative boundaries or whatever that might be. There are a variety of groups and entities which are trying to solve this problem or establishing this level of information exchange on a much larger scale than it is for just cross enterprise exchanges. There are projects in variety of countries. Some countries are much more advanced in establishing those. Could mention Netherlands, for example, or Austria, or a few other countries in the European Union. There is also a European Union-wide projects and initiatives to further move that. But we also see similar efforts in the US. The Sequoia project could be one of the examples where that level of exchange of healthcare information is extending way beyond a single region or single state, and could reach pretty much a national scale. One of the challenges is that the exchange of healthcare information is different from the exchanging the imaging information, just sometimes due to sheer size of objects and data that need to be exchanged. So this profile is addressing these demands and also looking a little bit further into the future by understanding the need for also a federation of communities. That means there may be one community that represents several others. For example, when the requests for patient imaging data may cross multiple boundaries from one country to another, and then from a country to a particular region or state or province. And finally, but not necessarily the least important, is that the source system, the system that actually usually produced the data and also decided to publish that for being shared, still needs to maintain full control over what information is shared to a community or cross-community access. Next slide, please. One who is familiar with developments of profiles in both IT infrastructure domain and in the IHE Radiology domain for quite a while might say that, well, that sounds pretty much as the XCA for imaging profile, or XCAI, which have been in trial implementation for quite a while, and just very recently has been promoted to the final text, and it is a part of IHE Radiology framework. And there are real life implementations of that profile. So what's the difference? There are a few things which distinguish the XC-WADO from the XCAI profile definitions and requirements. One is the XCAI relies on the XCA profile that also explicitly implement the actors of which explicitly implement the XDS affinity domain option to retrieve imaging manifests. The imaging manifests are being the documents typically encoded as DICOM KOS project objects that contain the list of images or instances, DICOM instances, which have been published by the source to be shared. It also relies on the older technologies such as SOAP and TOM web services to retrieve the DICOM objects across community boundaries. Modern infrastructures and development of DICOM standard in the recent years in actual practice strongly call for the RESTful web services to be used for access of DICOM objects, and also allows for accessing other representations of the objects, for example, rendered images instead of original DICOM instances, which makes a lot of value when you have to retrieve information from only for the reference purposes, and that retrieval has to cross multiple boundaries and cross multiple communities. Least important, but still the fact of life is that the XCAI profile is final text, and adding the use of DICOM web-based capabilities would require support of outdated technologies by the participating actors. And some of the implementers who are coming to the market and are interested in serving the needs which have been described earlier may not necessarily be keen to implement older technologies. So the new profile, the XC-WADO, focuses on the use of DICOM web RESTful semantics and allows cross-community operations not only between the XDS affinity domains, but also other environments such as MHDS domains or whatever maybe a future development in configuration of the healthcare communities. Next slide, please. So here's an example. We can implement the XC-WADO alongside with XCA with XDS affinity domain, or it could be association with the MHD domain, or a combination of both, or whatever that might be. The gray part on this diagram is an example of how things could be structured, but they are not part of the profile. So it's in the definition of the profile, the XCA profile semantics are being used for discovering and retrieval of published imaging manifests, and that is preserved in XC-WADO alongside with the same way as it is with XCAI. However, in XC-WADO, we are seeing the imaging document consumer using the new cross-community WADO RS retrieve RAD 160 transaction to submit the requests to imaging initiating gateway for retrieval from the remote community. And the same transaction is used by the initiating imaging gateway to communicate with the responding gateway. The responding gateway is expected to use the WADO RS retrieve, the very well-known RAD 107 transaction to retrieve document objects from the imaging document source and then deliver them back to the requester. So a couple of notes on this definition. One is the definition of the cross-community WADO RS retrieve transaction and associating it with both communication between imaging document consumer and imaging gateway, and also between gateways, allows for a very explicit definition of what can be done and cannot be done, and how things operate in the cross-community environment. Another note, you could see that use of some transactions is shown with dotted lines, which means that the profile is also very flexible, allowing, at least for scenarios where it makes sense, to initiating imaging gateway, for example, to communicate with imaging document consumer in any other way that might be not specified by the profile. And similarly, responding imaging gateway may communicate with imaging document source in its community by some other means rather than WADO RS retrieve transaction. So from this perspective, there is an option on both gateways which explicitly prescribes how to handle these defined transactions. Otherwise, you can simply group the actors and allow them to communicate in the undefined way. Next slide. Next slide. So key considerations of this profile. Probably first and foremost, it unambiguously defines how the RESTful requests for DICOM objects are formed and communicated between the document source and initiating imaging gateway. And it uses the home community ID of remote community and the content of imaging manifest to formulate that. Home community ID allows routing of the requests to the appropriate responding imaging gateway. Retrieve location UID, which comes from the manifest, identifies the imaging document source. It also can include the DICOM retrieval URL that could be contained in imaging manifests to facilitate a retrieval of DICOM objects by a responding imaging gateway. So if present, it is included in the request. Imaging manifests are retrieved from the remote community, may be modified by the source before imaging document source uses information from them. So that means when the retrieval actually occurs, the imaging document consumer has to be prepared that the information that it retrieves may not necessarily be exactly the same as they expected from the manifest. So that is also highlighted in the profile. The final note is I mentioned that the profile allows for retrieval of rendered instances. However, considering the complexity of the communication and transmission of the requests across multiple boundaries, multiple network environments, through multiple firewalls and other network security configurations, it's not it's allowed, but it's not required for the document source to fulfill that fulfill those requests, and the documents imaging document consumer should really be prepared to handle that. Bottom line is this profile has been drawn with the great help from a variety of participants. I already mentioned the folks from Netherlands, Austrian IHE group. I shall also mention the multi-country working group, which provided a lot of feedback and a contribution to development of this profile. This profile has been reviewed multiple times, and it's going to be published as a trial implementation in the next week or a couple of weeks, and at that time it will become available for everybody to further review, try to implement, and provide us a feedback, which we will always appreciate. That covers this subject.
All right, great. Next slide. So the last thing that we'll cover, and I think, Andre, you're going to cover this, is notable technical framework maintenance updates.
Sure. This is a fairly small list of items that we will also be able to cover in 2024-25 cycle. Alongside with development of 3 very notable profiles, we finalized 19 change proposals. Most of them are targeting very specific needs and improvements in the framework. Continued refactoring the older transactions so they could be easier reused in development of the new actors and transactions in the new profile development. We've added several fixes based on the real world feedback for AI results profile, which is in the trial implementation state, but seems to be very well accepted in real world and being used, and we will probably be considering promoting to final text fairly soon. We have completed CPs and promoted to final text 2 profiles. One is invoking imaging display. Again, the profile which has been used by a variety of vendors in real life environments, and even though a fairly simple profile, it serves the very real needs. And also CTMR perfusion profile, which is the content profile, which has been also on the books for quite a while. We also were able to identify 4 candidate profiles for promotion into the final text and 6 profiles for the retirement or deprecation. And we're looking at the profiles which have been in the trial implementation for a very long time, and we're analyzing them from the perspective of what these profiles have behind them. Do they have a valid use case anymore or not? Are there existing implementations? How is the technology which is being used in these profiles? So we're retiring profiles typically when they have a stale technology, but there are some implementations, so the use case is reasonably valid and still could be implemented in certain scenarios. So we will not maintain that profile any longer. We will not implement any change proposals for those profiles, but they could be found in the document in the published documentation, and they will be labeled as retired. We deprecate the profiles which use obsolete technology, or there is really no use case, they've never been implemented, and our recommendation is do not implement these profiles. Don't even look at them. Don't try to implement them. Typically, the deprecated profiles will have a very well developed modern replacement for them, and that's what typically would be a recommendation. These profiles will be removed from the TF publication. They will remain in the archive, but again, we will strongly recommend not to implement those profiles in any new developments. That is on the continuous maintenance. So we'll continue that in the following cycle. And I'll pass it back to Brad for other updates.
Yeah, absolutely. Thank you so much. We have one more slide just to talk about kind of what's next. We go through every year the process to consider new profiles and white papers. We have put out a call for proposals, and in about 1 week's time, that'll be the last day to submit proposals. You can learn more about the proposal submission process if you go to the wiki page on IHE.net. And that will walk you through, it's a short 1-pager on the, what is the problem statement? What are we trying to solve for? Why it's important that we do this in an interoperable fashion. Once we've got these proposals in, the committee will consider them. We will ask for detailed proposals. The technical committee will review those and do an assessment on these. They'll be presented back to the planning committee on October the 1st for approval for the 2025-26 year. That work will begin. The committee will meet in November, the tech committee, and we'll walk through creating those profiles and potential white papers. There will be a public comment period that starts around February, ends in roughly March. They'll be finalized for trial implementation around April and published around May. And so that is the workflow. It all starts though with the proposals. So if you haven't, if you're considering one, definitely get it in before the July 21st. And with that, we've got maybe 1 or 2 minutes for questions. I don't see any questions yet, except for will the slides be shared? The meeting it has been recorded, and Jamie, it'll be published on, I think, the IHE YouTube channel or reference from the IHE website, right?
Yes, that's correct. So once the meeting recording is ready for distribution, we will share it, and will also be posted to IHE International's YouTube channel.
Perfect. All right. And with that, any questions in the 1 minute we have remaining? See any? This has been fantastic, super informative. Thank you to all of the speakers and to the committees who've worked so hard on the profile development. It's exciting, and this is so important to drive the harmony between applications and radiology forward. So phenomenal work. We appreciate everything that the committees do and all the input from the community at large. So thank you so much, everyone, and enjoy the summer.